Hey everyone, in the last video we have got introduced to wireless LANs. We have seen what are the different characteristics of wireless LAN like advantages, disadvantages, then which factors we should consider before designing a wireless LAN product, and finally we saw the two types of wireless LAN which are implemented all over the world. Okay, so now in this video we will see these two types of wireless LANs are standardized by the IEEE. Its standard is defined as IEEE 802.11. So we will see the system and protocol architecture of this standard for both types of wireless LAN. So the first type was infrastructure based network. So it is standardized under IEEE 802.11. So on your screen you can see the diagram of infrastructure based wireless network or wireless LAN in which different entities are shown. So as you can see, there are several parts. One that is denoted in the center. This is called as a distribution system. Then there are two basic service sets, BSS, users, access points, and other LAN, other IEEE local area networks like Ethernet or wired LANs. Okay, so 802.x is denoted by that one. So what are the jobs of all of these that we will see in this particular session? First of all, we have to remember that in infrastructure based network, the communication between user devices, as you can see, this is one user, this is another user. So the communication between users happens through only the access point. Direct communication is not possible. So every uh, small part of wireless LAN will be associated with the access point so that all the devices in that area should be able to communicate with each other. So starting with each and every entity, first of all we will look at the station, that is user devices. Station is a terminal. It may be a laptop, it may be a mobile device, it may be a PDA, tab, or it can be anything which is able to wirelessly access the medium and contact to the access point. So if a user has to send a data, it has to first contact the access point, and to contact the access point you require a station. Okay, that is your mobile terminal. Then each access point forms a small area in which it is providing the services. So as you can see, this access point is covering this area in which it is providing a wireless services. Now this area is called as a basic service set. In this area, all the users which are present in this area will be using same radio frequency. So in short, I can say that each access point provides a set of radio frequencies which will be used by the users throughout the basic service set. Okay, so that is BSS. Then access point. What is an access point? An access point is nothing but a type of a router which is integrated into the wireless LAN. This is a BSS is nothing but my wireless LAN. So access point is integrated into the wireless LAN and the distribution system. So both systems are connected via an access point. Okay, then there is a portal, as you can see over here. Now portal is nothing but a bridge which connects a distribution system to other local area networks. These local area networks may be wired networks also. So it's nothing but a bridge which will connect a wireless LAN to other LANs. Okay, now the last part is a distribution system. The distribution system connects all the access points together. No matter how many access points are there, all will be connected together via a distribution system. Okay, so interconnection of a network to form one logical wireless LAN, which is called as now ESS. Here by mistake it is typed as a EES, it should be ESS. Okay, based on several BSS. So ESS is equal to summation of all BSS plus access points. So extended service set is summation of all BSS plus access points. Okay, so all this part inside the distribution system will be wired one. Through the wires, access point will be connected to the distribution system. So only part that is wireless is nothing but your BSS. BSS1, BSS2, these are wireless. Everything else will be wired one. So as you can see, to make this network work, you need several types of infrastructure, and that's why it is called as infrastructure based wireless network. Remember, all the communication within users or among the users happens through only the access point. Direct communication is not possible. Okay, so let's now look at the second type of wireless network, wireless LAN, that is ad hoc network. Ad hoc is nothing but a temporary network which is formed by the users without needing any infrastructure. So for ad hoc network, you will not see any access point. Access points are not present. Neither distribution system is present. These types of networks, as we have discussed previously also, are formed when there is a moment of crisis or there is a situation of emergency. So it allows you to have a direct communication within a limited range. So as you can see in the diagram, there are two different networks which are shown. These are called as IBSS, which is nothing but independent basic service set. Again, similar to infrastructure based network, this service set has a group of stations or users using the same radio frequency. So if you want to communicate from this laptop to this mobile, it is not possible because they are using different uh, radio frequency. So that is one of a drawback of this ad hoc network, that you are not allowed to communicate outside your independent basic service set. Stations, that don't no need to explain again. All the users which are using a mobile device inside a independent basic service set will use the same frequency, radio frequency, for communication. Now direct communication is possible in this one. Another important factor is the terminals which are used inside a network must be capable of routing as well. That is not required in the infrastructure based network. So station is nothing but your terminal plus a router. Okay, so in infrastructure only terminal equipment is necessary. Routing capabilities are handled by the access point. Okay, but in ad hoc network, a station will handle both mobile terminal as well as routing capabilities. Okay, so that is a important difference from infrastructure network to ad hoc network. Okay, also in the previous case, if you can see, this mobile user can communicate with this user through access point, distribution system, and second access point. That is possible in infrastructure, but in ad hoc network, this laptop cannot communicate with this particular mobile terminal because of change in the radio frequency in the two different IBSSs. Okay, now I said this is possible, although this radio frequency, let's say 10 megahertz or 100 megahertz for example, and this is 110 megahertz, still they will be able to communicate because of presence of wired network, that is access point, distribution system to another access point. We will see what type of protocols will be required for making this communication possible. As you can see in the infrastructure, you will require wireless protocols for basic service set, whereas wired protocols for distribution system as well as access point. So both types of protocols will be needed for infrastructure based networks. But in case of ad hoc networks, only wireless networks are present, no infrastructure is present in the ad hoc networks. So only wireless protocols will be implemented. So they are not standardized as a separate unit because all the nodes within the independent basic service set should follow same routing protocols in order to make communication possible. so they need not to be standardized. Everyone can agree, mutually agree with each other that they will use certain protocols and they can communicate. Okay, so standardization of protocols is made for infrastructure networks. So that's what we are going to see. IEEE 802.11 protocol architecture. Now as you can see in the diagram, here we are showing a communication between a wireless device, that is mobile terminal, and a fixed device, that is a fixed terminal. This fixed terminal is connected to internet, and via internet through bridge it is connected to infrastructure network. Infrastructure network is providing one access point to which this mobile terminal can access. Okay, so this is the connection setup. Either this may be transmitter, or this may be receiver, or vice versa. This may be transmitter, that is fixed terminal may be transmitter, and this may be receiver. Anything can happen. So this is the scenario. Now if you see the protocol stack for this communication, the upper three layers at mobile terminal and at fixed terminal, both are having same type of layers, application, TCP and IP. So they are not standardized by IEEE because users are free to choose their own protocols in this aspect. Okay, why? We will see later on. Then downwards comes again two layers. One layer is made up of LLC and MAC, out of which LLC is not standardized because again we will see the reasons later on. But one part of DLC, that is data link layer, that is called as a MAC, is standardized, and physical layer is also standardized. Okay, so IEEE 802.11 standardizes only two layers, that is physical layer and MAC layer. Okay, you can see since this is wireless part, you will see 802.11 at access point also. Access point implements both type of protocols, wireless as well as wired, because this connection is wireless and this connection is wired. So on this side you are using or access pointing using 802.3 protocols. 802.3 refers to Ethernet standard, so it is for wired. So access point has to be able to implement both types of protocols, that is wired as well as wireless. Then at the fixed terminal everything is wired, so only 802.3 protocols will be implemented. Okay, so we are going to see only two layers, physical and medium access layer, for protocol architecture which is standardized by the IEEE 802.11. So 802.11 fits seamlessly into other 802.x standards, that means other IEEE standards which are defined for computer networking for wired LANs. Application should not notice any difference apart from lower bandwidth and perhaps higher access time from the wireless LAN. So just now in the previous case we have said that first three layers are common. Why it is? Because this application should not worry how my data will be delivered to the destination. So they are not standardized. It is left up to lower layers to handle the mobility and all the delivery related tasks, and that's why you will see applications will not notice any difference apart from lower bandwidth in case of wireless part and higher access time because of lack of physical medium from the wireless LAN. So WLAN behaves like a slow wired LAN. Applications believes that they are sending a data over a slow wired LAN rather than wireless LAN. Consequently, the higher layers, because of this higher layers, application TCP/IP look the same for wireless as well as wired nodes. Okay, this is the reason first three layers are not standardized and they look same for wired as well as wireless nodes. So the upper part of data link control, that is LLC, covers differences of medium access control layers needed for different media. Okay, so what is the job of LLC? Covering the difference between how to allow users to access a medium for different media. Now, most of the time in our wireless LAN, media is nothing but air, free space. So again, no need to separately define standard for LLC. Okay, one standard can be sufficient for regulating the access, as well as upper three layers, that is application TCP IP, are not changed. So that should not, that means they are not considering any change in the type of medium access. So that's why LLC will not observe any difference, and that we are not defining it again. So in many of today's networks, explicit LLC layer is not visible because of this reason. Okay, most of the tasks are done by medium access, so LLC has nothing to do in that regard. So specific mention of LLC you will not see in the most of the today's networks. Okay, so let's look at the details of the two layers which are standardized by the 802.11. So you look now at the functions of each of these layers. Now on your screen you will see the diagram, which comprises of further more parts compared to the original protocol architecture. Now 802.11 standard only covers, this is important, physical and medium access layer like other LANs do, that is wired LANs. You can see the LLC is not covered in the 802.11. Okay, physical layer, this one is subdivided into two sub layers. First one is called as physical layer convergence protocol, abbreviated as PLCP, and second is called as physical medium dependent layer. Okay, that is another sub layer abbreviated as PMD. Okay, so this protocol stack, which is standardized, is again further divided into two parts. Left side of this diagram is showing you, let me draw it again. Okay, left side of this, these are protocol layers, and right side is a management layers. So IEEE defines two types of layers, one is a protocol layer and second is a management layer. In protocol layer, physical layer is divided into two types, PLCP and PMD as a sub layer. The basic, then the remaining is a MAC, which is having a basic task of controlling the medium access, that means the way in which users will access the medium, then fragmentation of user data depending on bandwidth available, and encryption in order to maintain the security. Okay, then PLCP layer, in this particular video we will see just general functions of these particular layers. Details of these layers will come in the coming videos. So PLCP layer provides a carrier sense signal, that means it provides a signal which is able to sense whether a medium is free or busy, and such signal is called as clear channel assessment or CCA. So PLCP layers primary job is, or PLCP sub layers primary job is to generate a carrier sense signal which will be able to provide the information regarding medium's availability. Okay, that can be used by the MAC layer. Okay, apart from that, it provides a common service access point, that is SAP, independent of transmission technology. What's the meaning of this one? Now, as the name suggests, is a convergence protocol. Okay, the way in which you are accessing the medium, based on that your transmission technology will change. Now, what is transmission technology? Transmission technology refers to the type of modulation that is used, or encoding or decoding that is used by the physical layer. So if you are accessing a medium in a different way, your transmission technology will change. So what does PLCP do is that it provides a common connection for all types of medium access layers or schemes and all types of transmission technology. The details of types of transmission technology standardized by IEEE we will see in the next video. There are basically three types. Let's say type 1, type 2 and type 3 are three types of transmission technology supported, and there are several types of medium access mechanism. Now for each mechanism there will be a suitability of a different transmission technology. So to make them interact with each other, a common access point is provided or connection is provided, and that is called as service access point. So PLCP sublayer provides this service access point for all MAC layer mechanisms and for all transmission technology. Okay, so the PMD sublayer handles the type of transmission technology, that is modulation and encoding or decoding of signals. So these are the functions of these two sublayers and MAC layer. Now protocol layers are covered. Now what are the functions of management layer, and what is the difference between protocol layers and management layers? Let's see that. Apart from protocol sublayers, the standard specifies management layer. There are three of them: PHY management, that is physical management, MAC management, and station management. Okay, now MAC management and MAC layer. Now what is the job of MAC layer? MAC layer provides the way in which medium will be accessed, that is free space will be accessed, whether you are using CSMA, CDMA, TDMA, whatever medium access method you are using, that will be decided by MAC layer. But MAC management layer supports the association and reassociation of station to an access point. So this is my mobile. How I will access the air, that is decided by MAC, and how I will be connected to access point via a wireless type, that will be decided by MAC management. Okay, so association, that means connection, and reassociation, that means reconnection in case of loss of connection of a station to an access point, is decided by MAC management sublayer or MAC management layer. Apart from that, when you change your access point, let's say you are currently in this access point and then now moves to the or roams around to the second access point or second basic service set. So this is one basic service set, this is another. If you roam towards the another basic service set, again association and reassociation problems will happen because radio frequency will change, and that again will be handled by the MAC management sublayer or MAC management layer. Okay, so roaming between different access point is also handled by MAC management layer. So association and reassociation, why it is so important? To provide the security, access point several times employs or implements security mechanisms like authentication. So it controls authentication mechanism, encryption, synchronization of station with regard to an access point, and power management to save the battery power. Okay, as we have seen in the network layer, that routing is different in case of wireless networks because power should be consumed, or power that is consumed during the routing should be minimum. So to save power, power management schemes are deployed, and that is implemented in the access point. So MAC management layer handles all these things like authentication mechanism, that means when you connect to the new access point, if it is not open to access, then you will have to authenticate yourself and your data will be encrypted, and for that encryption mechanism will also provided by the MAC management layer. Apart from this, MAC management also maintains a database called as management information base associated with MAC layer, MAC MIB. Okay, so this database is nothing but keeping information of all the management related activities in a central location. So MIB is maintained also by the MAC management layer. Okay, so this is regarding MAC management. Now let's go to the physical management. Now physical management and physical layer. Physical layer provides type of modulation scheme or encoding or decoding scheme, which type should be used, that is decided by physical layer. Now physical management layer includes channel tuning and physical management information based maintenance. So once you have decided modulation and encoding decoding technique, then if the medium is free, you will try to access the medium, and trying to access a medium means tuning to the desired frequency. Okay, so if a medium is free and let's say 100 kilohertz or 100 megahertz frequency is available, and my current radiation is at 97 megahertz, that is user devices radiation is at 97 megahertz, then to move from 97 to 100 you need a channel tuning, that is done by the physical management. And similar to MAC management, Physical management also maintains a information database, and maintaining that database is done by the physical management layer. Okay. Then finally, the station management layer, which interacts with the both management layers and responsible for additional higher layer functions. Now, what is additional higher layer function? That is, for example, control of bridging and interaction with distribution system in case of an access point. So what station management does, how access point is connected to the distribution system, that will be controlled by the station management. So this is my distribution system. Sometimes there will be portal also. So how portal will get connected to distribution system, that will be handled by the station management. For that, it interacts with both Mac management layer as well as physical management layer. Okay, so that is the job of station management. So this is overview of different protocols used in this wireless LANs. From the next video, we will see each layer in detail one by one. So first, in the next video, we will see, in the next video, we will see physical management layer or physical layer. Then we will see MAC layer. Okay. So that's all for today. Thank you.